No. Because here's the 0 mark, right above the ruler. There are two distinct families that are always positive. What families are they? What elements are not becoming more stable when they gain an electron?
Alkaline metals.
Not the alkali. What?
Alkaline earth.
Yeah, the alkaline earth. The second family, beryllium, magnesium, calcium. Look, those are the highest, even higher than the noble gases. But also the noble gases are up there above 0 too. Helium, neon, argon. The noble gases, and so look it up here. These elements are not crazy about gaining an electron. These elements are not crazy about gaining an electron. What do those two families have in common?
Full shell.
They have just completed an energy sublevel. Even these have just finished the S, and now the next electron would go into a P. Anytime an atom has to start a new energy sublevel, even if it's just a sublevel, it's not favorable. In fact, as I mentioned, these are even less favorable than the noble gases for gaining an electron. All right, so that's what the story is, and I just have 3 little bullet points here. The positive one, you should know what elements have a positive electron affinity, or what families of elements have positive. You don't have to memorize general trends. You don't have to say, oh, as we go across generally, they become more negative. That's kind of true, although not really. Here's lithium, and here's neon. So from lithium to neon, you got up, down, down, up, down, up. So don't worry about trends. Just know with electron affinity what two families tend to not be negative. What two families tend to not want to gain electron. Yeah.
The alkaline metals are favorable in games.
None that I know of. I think they're all positive.
Lithium is negative. Lithium.
Oh, alkali metal. I'm thinking alkaline earth. Yeah, all the alkali are negative. They're not very big negatives, but they're all negative.
Why they try to use an electron? So what they rather keep one?
I know, but I mean, it's not that they're comparing gaining or losing. When you add an electron to lithium, there's room for it because it's an S1 term, and so if you add another electron, there's already a free spot in an orbital for it, so it just goes in. It gives off a little tiny bit of energy.
So it would rather be in the higher energy level than go to 1p6. Or no, 2p6. Instead of
No, this is not about what it would rather do. You're adding an electron into it, and even the alkaline metals say, okay, fine, I'll have an electron. You make the Na negative 1 ion. Weird. Yeah? There's not real good, clean trends for the transition metals with any of the periodic properties. I don't really know. I don't think that zinc, cadmium, and mercury would tend to gain, to favorably gain an electron. I don't think they would, for the same reason. But I don't really know because, like I say, the transition metals, they don't have good, clean trends. You see that they stopped at calcium. That wasn't on accident. That was on purpose. Because after calcium, we start the transition. And Chani, do you have a question?
What is it? Wait, so the higher the affinity, the more readily it accepts the electron?
Yeah, no. The more negative the affinity, the more readily it accepts an electron. All right, my friends. This stuff is really important, but my gosh, it's so boring. Look at this girl. I feel so bad. I put her to sleep.